So today we have a nice geometrical problem. This question was originally posted by Breathe the Math Guy. Now for a better explanation to the given date of this question, you can have a look at the clip from his video.
Here's the problem. Define a rectangle HOMF. The longer side of the rectangle is length 11, the shorter side of the rectangle is length 5. Next, construct a circle with center O that has a triangle ABC circumscribed within it. H is going to be the intersection of what are called the altitudes of this triangle. Those are the lines coming from the vertices that are perpendicular to the opposite side of the triangle. So we have these right angles. Finally, we have M as the midpoint of the side BC, and the question, what is the length of side BC?
So now let us see the solution. How can we solve for this? First of all, it was given that this particular quadrilateral PEDM is a rectangle. So the angles are 90 degree and opposite sides are equal. So if the top is 11, so DM is also equals to 11. ED is 5, so PM is also going to have a length that is equals to 5. Now it was also given that this point P is the center of the circle. Now what we can observe is that there is a circle, there is a chord, and from point P, means from the center of the circle, there is a perpendicular to the chord. Now there's a theorem that if there's a perpendicular from the center of the circle to the chord, it will bisect the chord. And the proof is also very simple, just join from here to there and from there to here. This and this are equal because they are the radius centered at the boundary. Now these two triangles are congruent by right angle hypotenuse side, right angle hypotenuse and this side. And when these two triangles are congruent, their rest part becomes equal. So from there, this length is equals to that particular length. So DM is having a length that is 11. So let BD be equals to A. So the complete length from B to M is 11 plus A. So MC is also going to have a length that is 11 plus A. So the length of M to C is 11 plus A. Okay. PM is having a length that is equals to 5. From P to C, if I will join, it is going to be the radius. So what I have is the right angle triangle present over there. So first of all, let me remove this here and draw that particular right angle triangle that is PMC. So we have a right angle triangle PMC. This is point P, this is the point M, and this is the point C. Here is the 90 degree. PM is having a length 5, MC is having a length that is 11 plus A, and PC is the hypotenuse and it is the radius of the circle, that is R. So now applying the Pythagoras theorem in this, so 5 square plus 11 plus A the whole square, and that is going to be equals to R square. This will be kept like this way only, not to open the brackets and all the things. This is the equation 1. Now look carefully in this right angle triangle ABD. So in ABD, if I will consider this angle as theta, okay. Now again look carefully in this right angle triangle that is BCN. So in the triangle BCN, we have a 90 degree, we have theta. So by angle sum property, first of all, let me remove this thing, it is not required anymore. So by angle sum property, we have this particular angle as 90 minus theta, okay. Now look in this right angle triangle EDC. In this right angle triangle, we can see here's the 90 degree, one of its angle is 90 minus theta. So by angle sum property, we have this particular angle as theta. Okay. Now what I will do is, this is a right angle triangle, that is triangle ABD. So triangle ABD is there, and the other right angle triangle is triangle EDC. You can have a look to these triangles in the diagram. So we have other triangle that is triangle EDC. These two right angle triangles are there, they are containing this angle theta. Now what I will do is compare the value of tan of theta in these two right angle triangles. Now according to this right angle triangle ABD, the value of tan of theta is going to be equals to opposite upon the adjacent, and that is equals to AD upon A. And now the value of tan of theta according to this triangle EDC. So in triangle EDC, the value of tan of theta is opposite upon the adjacent, opposite side is D to C. And D to C, the length is 11 plus A, that is 22 plus A. So 22 plus A, and the adjacent side is equals to 5. So from these two right angle triangles, we have these values of tan of theta. Now you can just do a cross check between these right angle triangles and the value of tan theta that we have just written. So from triangle ABD, the value of tan of theta is AD upon BD, that is A, all good. From the right angle triangle EDC, the value of tan of theta is 22 plus A upon 5. Yes, they both are correct. Now we can see that in this both the LHS is equal tan theta, and now we can compare their RHS. So AD upon A is going to be equals to 22 plus A upon 5. After the cross multiplication, I will have the value of AD that is going to be equals to A into 22 plus A upon 5. I will keep it as it is, the value of AD. Now I will just go back to the diagram and draw one more line segment, that is from point A to the point P. So from point A to the point P, let it be clear, yes. So from point P to the point A, this is 90 degree because of the linear pair. Now PA is the radius of the circle centered to the boundary, so it is going to have a length R. And I'm just drawing that particular right angle triangle also out of this diagram. So here it is P, A and all the things. So here's the point P, here's the point E, and there's the point A. Here's the 90 degree. EP is already having a length that is equals to 11. PA is having a length that is equals to R. Now in this right angle triangle, we have the base, we have the hypotenuse, but the perpendicular is missing. Now let us have the perpendicular also. So look in this diagram, the complete length of AE is ultimately going to be equals to the longer length, that is AD, minus the shorter one, that is AD. Subtraction of this both line segment will give me the length of AE. Now we have just found the value of AD, that is A into 22 plus A upon 5, and AD is already having a length that is equals to 5. So ultimately we have the value of AE, that is A into 22 plus A upon 5 minus 5. This is the value of AE. And now we can see a right angle triangle is there, so we can apply the Pythagoras theorem. So the value of AE I have just written over here, so square of 8 plus the base square, that is 11 square, and that is equals to R square. Now remember this first equation, that R square is equals to 5 square plus 11 plus A the whole square. So 5 square plus 11 plus A the whole square, if I will open it, so it will give me 11 square plus A square plus 22 times A. Now with the help of algebraic identity, opening this up, x minus y the whole square, that is equals to x square. So A square into 22 plus A the whole square upon 25 plus the y square, that is 5 square, minus 2 times x, that is A into 22 plus A upon 5 into the value of y, that is equals to 5, plus 11 square, that is this one, and that is equals to 5 square plus 11 square plus A square plus 22 times A. And now I can see that 5 square, 11 square, 5 square, 11 square, 5 and 5 got cancelled out. So what is remaining is A square into 22 plus A the whole square upon 25 minus 2 times 8 into 22 plus A, and that is equals to A square plus 22 times A. I can take A common, so 22 plus A. And now from the LHS and RHS, we can say that A into 22 plus A can be cancelled out, and that value is not going to be equals to 0 because it is a side length. So A into 22 plus A into 22 plus A got cancelled out, and here it is squared, so a single value will remain. So A into 22 plus A after opening the bracket will give me 22 times A plus A square upon 25 minus 2, and that is equals to 1. Now we can simplify this thing so as to get that A square plus 22 times A minus 75 is equals to 0. So now we have a quadratic equation that is very easy to be solved. We can just use the factorization method. So A square plus, now 22A can be splitted as 25A minus 3 times A minus 75 is equals to 0. Now from this 2 I can take A common, so A plus 25. From that both I can take negative 3 common, so A plus 25, and that is equals to 0. And now I can see that A plus 25 can be taken common, so A plus 25 taken common, so inside the bracket A minus 3, and that is equals to 0. So now either this is equals to 0 or that is equals to 0. So if this is equals to 0, A is equals to negative 25, and if that is equals to 0, A is equals to 3. Now look carefully that the A in this particular question was considered as this side length, that is from B to D, it was considered as A. So that value cannot be negative because it is a distance. So we'll go with the only positive value, that A is equals to 3. So the value of A is equals to 3, and the required question was to find the value of BC. So we have the length of BC, that is 2 times 11 plus A. According to this question, the length of BC is 2 times 11 plus A. So that is equals to 2 times 11 plus 3, that is 2 times 14. So the value of BC is going to be equals to 28, and that's the answer. That the length of the chord BC is 28. So this was my way to solve this particular question. If you have any other method other than mine, other than Breathe the Math Guy, you can do comment below, and if it's hard to comment, you can email me or else you can DM me on my Instagram. The links are in the description.